Hello students. So today we will be discussing about derivative, okay? So in our earlier two session we have seen the limit, continuity and the existence of differentiations. Yes. So today our discussion is mainly, or I would say overall, will be remain focused on differentiation, derivatives and all those kind of stuffs, okay? So starting with the basic definition. As we already know that we say a function fx is differentiable if and only if, or in short form we write this as if. Whenever you will see this notation, it means this: if and only if, okay? This is a short form of writing this whole phrase, okay? So we will say that fx is differentiable if this both the left hand limit and the right hand limit exists and they are equal, right? We know this from our earlier two session. We have did several problems also based on this. It will be H. Yes, we know this, right? So today we will start from here. So once we know that limit exists, we will now assume that f is differentiable. So in a single line we will say that limit h tends to 0, fx plus h minus fx by h. This expression exists, okay? Because f is differentiable. We say f is differentiable if and only if these two limit exists and equal, and when we already know that these two limits exists and equal, or in other words, when we are already know beforehand that f is differentiable, then we will only deal with this expression, okay? We will only deal with this one. We will not bother about this one. When you already know, that is, it was given already in the question that f is differentiable. So we will start from here. We will not bother about these two different individual expressions and check again, okay? Okay, so today we will start from here. We know that f is differentiable, therefore we will start from this expression. Okay, so basically this is known as the first principle, okay? We call this as first principle, okay? So sometimes in the problems, in the questions, it will be given to you that derive, or a function will be given to you, say for example, example 1. Let's say fx equal x square, okay? Now you would be given in the problem that find f dash x from first principle, okay? So how you can solve this problem, okay? Okay, let's solve it now. You will get to know how to do it, yes? So it is given fx equal to x square. We have to evaluate f dash x from first principle, that is from here, okay? Okay, so we have fx equal x square, therefore fx plus h, this is x plus h whole square, right? Now the first principle, what is this one, is the first principle, right? So we have, let's evaluate the ratio first, fx plus h minus fx upon h, okay? This is x plus h whole square minus x square by h, yes? Now we know this formula, right? This is the formula of a square minus b square, okay? What is the formula for this one? It is a plus b, a minus b, yes? So here we have our a is x plus h and b is x, right? So a plus b x plus h plus x, and a minus b, x plus h minus x upon h, right? So this equals 2x plus h times h upon h. H and h will get cancelled out because h is not equal to 0, right? H is close to 0 but not equal to 0. Therefore, this gives us 2x plus h. Okay? Now, if we now take the limit, this is limit of, as we have derived here, the whole expression boils down to this form. Therefore, this we can write 2x plus h. H tends to 0, this is 2x. So, from the first principle, we evaluate the limit fx, f dash x is 2x, right? Okay, let's do some more examples on this so that you can understand. Or if you already know, then it would be helpful to revise yourself, okay? Let's say fx equals, say, sine x, okay? Now you have to derive f dash x from first principle. You can try it by yourself, okay? We have fx equals sine x. Similar procedure, fx plus h is sine of x plus h. Whenever you will see x, you just replace that x by x plus h, okay? Let's say you have given fx equal exponential of x. Therefore, fx plus h, it is e. You will replace x by x plus h, okay? X in this way. Same method, we will first compute the ratio. Now, you know this formula, right? Actually, we can apply this formula, sine x plus h. This we can write in this way, sine x cosine h plus cosine x sine h. Yes, this is a formula of sine of a plus b. Yes, sine a cosine b plus cosine a sine b, right? I am just implementing this formula here. So if we write down the formula, sine x cosine h plus cosine x sine h minus sine x upon h, right? Now there is nothing so difficult here, we just have to simplify, right? So sine x, so if we now take this sine x and this sine x, we can take both common and we obtain here cosine h minus 1 plus cosine x sine h upon h. This gives us sine x times cosine h minus 1 upon h plus cosine x sine h upon h, right? Now we will take the limit to both left hand side and right hand side, and this is our f dash x, okay? Since let me do this in the next step. In this step I am just taking limit to the both left hand side and right hand side, that's all. Yes, I hope there is nothing so doubt here. So now what I am saying, since sin x is free from h, therefore we can put sin x outside of this limit, okay? Sin x times limit h tends to 0 cosine h minus 1 upon h. Similarly, since cosine x is free from h, we can put this limit inside, cosine x outside of this limit. H by h. Okay, so now we know that this limit is 1, right? That we know limit h tends to 0 sin h by h equals 1. Yes? So we'll just substitute the value. We have to apply some formula here, so I will do that in the next step. But right now, whatever is known to us, let us evaluate those parts. Yes, from here. So as I said, we need to put this in a special form. So see, cosine h minus minus 1 upon h. We have a limit. Limit h tends to 0. Now you know that I'm using different color. There is another formula of cosine. It is a multiple angle formula, that cosine 2 theta. You can write this in this way: 2 cosine square theta minus 1. You can also write this in this way: 1 minus 2 sine square theta. Okay. Now see, you have here cosine h minus 1. Therefore, we are not going to use this one, okay? Because if we take minus 1, then this 1 will not get cancelled out. Yes. But if we use this formula, this both formula are equivalent actually. You can prove this, that this equal this one. But if we take this one, then minus 1, then this one will get cancelled out, okay? So you will use this one. And in this case, we have our 2 theta equals h, right? Therefore, theta equals h by 2, yes? So, substituting the value here, limit h tends to 0, we have cosine h minus 1 by h. This gives us limit h tends to 0. So we have theta equals h by 2, therefore it will be 1 minus 2 sine square h by 2, yes, minus 1 upon h, correct? Yes, because our 2 theta equals h, therefore theta will be h by 2. This is h, therefore this would be h by 2, yes? Nothing so difficult to understand here, right? It's easy. Limit h tends to 0. This 1 and 1 will get cancelled out. Minus 2 sine square h by 2 upon h, correct? This we can write minus 2 outside of the limit. H tends to 0 sine square h by 2 upon h, okay? Minus limit h tends to 0. This we can write in this way. See, if you have any doubt, let me know. Sine h by 2 times sine h by 2 upon h by 2. Yes, I just put this 2 below the denominator, because you know one thing, right? This 1 upon 1 by 2, this is basically 2, right? So what I did, I write 2 as in this way. 2 equals, since we have a h here, so I write this as 2 by h in this way, 1 by h by 2. Yes? Okay, so now we know that this one is 1, right? Limit t tends to 0, sine t by t equals 1, yes? And here we have our t is h by 2, therefore this part will be 1, yes? And So h tends to 0, we can write in this way. This one is, I am using different color. This one is 1 and this one is 0. Yes, because limit h tends to 0, sine h by 2 will also tends to 0. Therefore, finally, we have from here this equal 0. Okay. Okay. So, what do we obtain finally? We obtain this is sine x times 0. This whole limit boils down to 0, right? Because this is 0 and this is 1. Therefore, this times 0 plus cosine x times 1, this equals cosine x. Okay. Therefore, from the first principle, we obtain f dash x equals cosine x. Okay. So now let's do some harder problem. In the sense, it has some special tricks. Okay. Let's say example 3. I am using different color for the question. Given that fx equals, let's say, x plus 1 upon x minus 1. Now you have to prove from the first principle. From the first principle f dash x, you have to evaluate it. From first principle, okay? Starting from the definition, we have fx plus h is, as I mentioned, just replace x by x plus h, that's all. X by x plus h. And we already have fx. Therefore, if we now calculate the ratio fx plus h minus fx, you try this yourself, okay? Don't follow my session every time. You should also try this upon yourself. Only then you could learn, okay? There is nothing so difficult here. You just have to do some computation, that's all. And maybe some tricks required, which is also very simple. I mean, a trivial tricks, not so difficult, okay? So we have fx plus h minus fx. I just apply the definition here. And if we now simplify this, we have x minus 1, x plus h minus 1, okay? If we now simplify the numerator, what will happen? Let me use some different color. We have x square. I am just simplifying in. That's all. Nothing so. Okay. See x square. It is simple. X square minus x plus hx plus 1 in this way. Minus, and in this case, what we will have? We have x square plus hx minus x plus h minus 1. Yes? Okay, now there is nothing so difficult here. You just have to simplify, and we can put this one in the denominator. Yes? 1 by a by b, this equals 1 by ab, right? And in the numerator, what we have? We have this x and x will get cancelled out. Let's use black color. This x and x will get cancelled out. Similarly, here also x and x will get cancelled out. And this x square will also get cancelled out. Yes? So we have this hx will also get cancelled out because we have minus. So whatever will remain in hand, so this minus h and minus 1, oh, this will also get cancelled out. Minus 1 will also get cancelled out because minus 1 minus minus plus 1. So only h will remain from both the terms. From these terms and these terms, only h part will remain. So here we have minus h. Sorry, I was using blue color. So here we have minus h, and in this case minus of plus h, that is minus h. This is minus of 2h, x minus 1, x plus h minus 1. Yes, and we have a h here. Let me use this. Yes, so h and h will get cancelled out. This is 2 upon x minus 1, x plus h minus 1, right? So we obtain this ratio as minus 2 x minus 1 x plus h minus 1. Now if we take limit to both sides, I am not writing the expression again. So if I take limit to both sides, you have minus 2 x minus 1 x plus h minus 1. Here just substitute h equals 0. We obtain 2 by x minus 1 whole square. Okay. Therefore, from the first principle, we obtain that f dash x equals minus of 2 x minus 1 whole square. Okay. Similarly, you can also prove that from the first principle, if fx equals given as, say, x to the power 4 or cosine x or logarithm of x, in all these cases you can prove the result from the first principle, that if f dash x equals 4x cube, this one is minus sine x, this one is 1 by x. So you try this, it would be a good practice for you, that how to derive this formula or this result from first principle for these functions. Yes? Okay, so now let's move on to another part. We will learn about chain rule, okay, which is very important actually. So let's say if G is a and F is also differentiable. I am assuming that both f and g are differentiable over whole R, okay? That is set of all real numbers, okay? Then, but actually the theorem is on, it is a point valued theorem. That is, you will see in the book, they have mentioned that in some point, say at x, g is differentiable function at x, f is also differentiable at x. I am not going to that confusion. I am assuming that it is differentiable over whole R. Then the composite function f of gx, which we also write as f o gx in this way, yes, is also differentiable, okay? And we write that f dash gx, that is a differentiation of this composite function, okay? I think it would be better if we can write in this way. Actually, this is the symbol f in this way. Then this is actually f dash gx times g dash x, okay? This is the formula for computing the differentiation of a composite function. We have seen the composite functions, we have did lots of numerical problems on composite functions, right? So how to calculate the differentiation of a composite function? So this is the theorem, and based on this we will do some problems now. But you do not have to worry about this theorem. I am doing some problem now, and you will see that everything will boils down with simple some strategy. Okay, you just have to remember the strategy to solve these types of problems. Yes. So let us give some example first. Let's take some simple example. Let's say y equals f composite of gx, and this say sine of x square. Okay, this is a composite function type, right? Because our gx is x square and our fx is sine x, right? So you see that f composite of gx, this is f of gx sine of gx, right? Because f of x is sine x, sine of gx is x square, sine x square. Yes. So this is basically our gx in this case is x square and fx is sine x. So the composite function theorem is saying you differentiate fx and you differentiate gx and then multiply both. Now you can do this problem in two ways. Either directly apply the composite function theorem, which might be confusing for you in the beginning, or you can follow a separate tricks. I am also going to show that also, but before that I am solve this problem with the help of composite function theorem directly from this theorem. It will be one line. If you are already aware about this formula, composite function theorem formula, or chain rule, which is basically called as, this is also known as chain rule. So if you are already aware about this, have done some problem, then I hope it would not be difficult for you to understand this, that how to obtain the answer directly from this formula. So it is saying that differentiate f. So what is our f? X is sine x, right? But you need to have gx inside. So what is the differentiation of sine? It is cosine, right? But we need to have gx, therefore it would be x square. And then we need to differentiate our gx. What is our gx? Our gx is x square, right? Differentiation of gx is 2x, yes. Therefore the answer is 2x cosine x square, right? Yes, I did nothing so fascinating things about here, right? I just applied the formula. I just perform the differentiation of fx that we have already seen. Sine x differentiation of sine is cosine, but instead of x we have gx here, so I put gx cosine of gx, that is cosine of x square, and then I differentiate gx, and differentiation of gx, that is gx is x square here, therefore differentiation of gx is 2x. I just applied the formula and multiply as given here. I just have to multiply. Okay, now let's look at the another part, which is the beginning. As a beginner you should follow in this way so that you can understand, and it is easier to do in this way, solve the problem. Okay, so let's now follow the alternate approach. We have our y equals sine x square, and as mentioned, let's say gx equal x square. Okay, now the chain rule, from the chain rule we can write this as dy dg dg dx. Okay, so y equals sine of x square, yes, and this we can write this sine of gx, yes. So sine of g, let's for the time being forget about this bracket x part. Now what is dy dg? Dy dg is cosine g, yes. Now bring back this gx into the picture. Now multiply this expression with dg dx. Now dg dx is 2x, yes. Now let's substitute the value of g. Our g is gx and gx is x square, so this is cosine x square. Yes? Okay. I hope you guys understood this, right? There is nothing so difficult here. Also, don't worry, I will give some more examples so that you can understand much better. So let's take another problem. Say y equals tan square x. Okay. Now I will solve this problem with both the method. Directly from the formula, which is coming from here, and with this method. This is also the same formula, but this is some sort of strategically easier to do for, especially for the beginners. Okay, so I will follow both this approach. So in the first approach, directly from the definition of the theorem. So in this case, can you tell what is our fx and what would be our gx? You have to individually write it down first. Okay, what is our fx, what is our gx? You have to determine that first whenever we are solving this problem with the help of directly from the definition, that is directly from the formula of the composite function theorem or the chain rule. So in this approach, what is our fx and what is our gx? Well, it is a bit tricky here. We have our gx equals tan x and our fx is x square. Okay, why? Just check it. See, f of gx is gx whole square, right? And gx is tan x. Yes? So in this case, our fx is x square and gx is tan x. So now, if we are following the definition of the theorem, then it is saying it is f dash of gx, then g dash of x, right? So our g dash of x is simple, we know. Differentiation of tangent x is secant square x, right? Yes? And differentiation of f dash gx. So we have to determine f dash gx. Now what is f dash x? Our f dash x is 2x, right? Because fx is x square, therefore f dash x is 2x, therefore f dash gx. What would be? It would be 2 times of gx, and we know our gx is tan x, therefore this is 2 tan x. So we obtain 2 tan x secant square x. Yes? Any doubt for this? Let me repeat it, what I did. See, this is the formula, right? F dash gx times g dash x from the theorem. I am following the first approach. Since this is a formula and we have our gx is equal tan x, therefore g dash x, we know from the formula the differentiation of tangent x is secant square x times f dash gx. Now our fx is x square and differentiation of fx, that is f dash x, is 2x, but we have gx here, so replacing x by gx, it would be 2 times gx, and we know gx is tangent x, so we just substitute the value of gx and substituting the value here and multiplying, you obtain the final result. Okay, so this is the one approach from the definition. Now we will solve the same problem with this strategy. Okay, that is this alternate method. So I am using different color now for the alternate approach. We have y equals tangent square x. Okay, so let's say our gx is tangent x. Observe that in this case you do not need to bring two functions like in earlier. You need both the function fx, gx. You have to determine it first, that which one is our fx, which one is our gx. In this case it is not required. In that case, as what I mentioned, it is easier for the beginner to approach in this way. It would be easier for you. Okay, once you get your expertiseness in this approach, then you can go over on this. Okay, then from this chain rule we have dy dx is dy dg times dg dx. Yes, now what is our dy dg? Our y is g square. Yes, therefore dy dg is 2g. Yes, and dg dx is tangent x differentiation. Similarly, secant square x. Now substituting the value of g is tangent x, tan x time secant square x. Okay, let's do some more problem. Say y equals this one. Okay, you try this by yourself, either one of this method, either the from the definition or from the alternate approach. Okay, meanwhile I am solving this problem. So I will solve with both the method, from the definition, that is from the theorem of the chain rule, and from this substitution method. So in this case, our gx, what is our gx? Our gx is x square plus 1, right? And what is our fx? Our fx is root x, yes? Because if we replace x by gx, then this thing is coming. Simple. Actually, this one is also easy if you can determine the function individually. Okay, once you can determine the function separately, you are done. After that, you just have to substitute in the formula, that's all. So the formula is f dash of gx time g dash x, and we know our g dash x, what is the differentiation of this one? It is 2x plus 0. Differentiation of 1 is 0 and differentiation of x square is 2x times f dash gx. What is our fx? Our fx is square root of x. One moment. Our fx is square root of x, therefore f dash x, this is half x half minus 1, this is x to the power half, right? So this becomes 1 by 2 root x. So from here we obtain 1 by 2 root of gx, correct? Not x, gx, because it is f dash gx. So this equals 2. Now we will substitute the value of gx, x square plus 1 times 2x, simplifying we have x by. Okay, now we will follow this alternate approach. We have y equals square root of gx, right? Now dy dg from the chain rule times dy dx from the chain rule is dy dg times dg dx, correct? Now dy dg is same method, half root g times and g dash x times g dash x, this equal g times, what is our g dash x? Our g dash x is 2x. This gives x by root g. Now you substitute the value of g here and you will obtain the same thing. Yes. Okay. I hope you guys have understood this, how to solve this type of problem. If you have any doubts, do let me know. Yes. So now let's do some problem on multiplication and division of differentiation. Okay. So first I will write down the formula and then I will show you some example based on that. Let's say you have a function, say fx, in this way. Let's write this as f1x. Say fx time gx. Both f and g are differentiable, okay? Then the formula for f1 dash x is this: f dash x times gx plus fx time g dash x, okay? Follow the order. You first differentiate f, then multiply with g, then differentiate g, and then multiply with f, then add both of these, okay? When you have division, say fx by gx, assuming gx is not equal 0 in the domain of the differentiation, okay, at least, then what is the formula for f2 dash x? I am noting down this formula as 1, and this I will write it down as 2. So here the formula is something like this. You first differentiate f dash x, you first differentiate f, obtain f dash x, then multiply with g, and then you differentiate g dash x, and multiply with f. See, it is same. Differentiate f, then multiply with g, differentiate g, then multiply with f. But from here, after here, the difference start from this formula with this formula. In case of product, in case when you have multiplication, you have a symbol between them is plus, okay? But when you have division, the symbol between them is minus, okay? And in the denominator, you have this thing, gx whole square, okay? Observe again, you first differentiate f, you have, okay, let's start from here. You have fx by gx. And what is the differentiation then? You first differentiate the numerator, that is f, and then multiply this with denominator, that is gx. Then, for the time being, forget the symbol. Then what you did? You then differentiate the denominator, then multiply with the numerator. Once you did, then put the symbol, negative symbol between them. So what is first? Differentiate the numerator, then multiply with the denominator, then again here differentiate the denominator, then multiply with the numerator, put the symbol, and then denominator square, okay? And in this case order is not so important because the symbol is positive, right? But if you remember in this way, then it would also helpful for you to solve this type of problem also, okay? So it is better to remember this in the same order. f dash g plus, f dash g dash f, then plus, and here f dash g dash f, then minus by g square, okay? Okay, I hope you have understood the formula, and once you do 3-4 examples, you will be automatically get remembered the formula, so there is nothing to worry about it, okay? Okay, so let's do some problem first. Simple problem I will start with. Let's take f1x is x square sine x, okay? And I will do the same thing with f2x with the same function. Let's say this as x square upon sine x, where x is, or I will write in this way, x is not equal in pi, okay? Because otherwise the denominator will be 0, yes, where n belongs to z, okay? Okay, so we will first, this is our fx, this is our gx, this is our fx, this is our gx. I will do both the problems simultaneously so that you can understand it and quickly grasp it, okay? So if I now differentiate, so as I mentioned, f dash g dash f, then plus. What is our f dash? Our f is x square, therefore f dash is 2x times g, plus what is our g? Sine x, g dash is cosine x times f 2x sine x. Now we'll just substitute the value x square cosine x. So this is the formula. I mean, this is the answer. And in this case, we have f dash g dash f, negative symbol, by g square, okay? f2 dash, this gives f dash 2x g dash cosine x times f by g square. Now substitute the formula, substitute the value 2x sin x minus x square cosine x by sin x whole square. Yes, where x is not equal n pi, n belongs to z. Yes, okay. I hope you have understood this, right? There is nothing so difficult here. Yes, let's do some more problem. Let's say f1x is x square plus x5 times sine 5x, okay, and f2x is, let's take these functions only, by sine 5x. Try this yourself. Yes, try this. It is not so difficult. Meanwhile, I am solving this here. You may pause the video and check it back later, whether you are right or wrong. Nothing so difficult here, so nothing to worry about it. So you have f, this is our f, yes, and this is our g, right? Similarly, for this problem, this is our f, sorry, I am using red color. This is our f and this is our g, yes? Okay, so let's now solve it. So the formula is f1 dash is f dash g, g dash f, then plus. Now what is our f dash? Our f is, let's do some rough work here. I am doing some rough work here, okay? Maybe later on I will erase it. Our f is x square plus x5, right? Therefore f dash, differentiation of x square 2x, differentiation of x5 5x4, yes, and our g is sine to the power 5x. Therefore g dash, can you do it by yourself? See, here you have this composite function, right? Recall, we did this few minutes ago. We have had at that time tan square x. So how we did that? Tan square x, remember? You have to apply chain rule here to obtain the differentiation of this function. And what is this and how you are going to apply that? Let's say our u equals, I am using some different color to showing the chain rule. Our u, say sin x, okay, so g is basically u5, right? Therefore dg dx is dg du times du dx, right? Yes. So if I now evaluate with this strategy, we have dg du, that is differentiation with this, it is 5u4 times then du dx. Our u is sin x, it is cosine x, yes. Now substitute the value of u, you have 5 sin x power 4 times cosine x, we can simplify this, 5 sin 4x cosine x, okay. So this is our g dash and this is our f dash. We will now just substitute the value here, that's all. 2x, sorry, it will be blue color. I am making mistake with color, choice. F dash 2x plus 5x4 times g plus our g dash is this quantity 5 sin 4x cosine x times fx. What is our fx? Our fx is this one, x square plus x5. Yes, substituting the value to x plus 5x4 times our g is sine 5x plus 5 sine 4x cosine x x square plus x5. So this is our f1 dash x. Okay, now we have to evaluate this one. We have f2 dash x. The formula is f dash g dash f minus upon g square. Our f dash, what we obtain our f dash? This quantity 2x plus 5x4 times g. Our g dash, what we obtain? 5 sine 4x cosine x times our f is this one. Okay, x square x5. Yes, symbol minus, and below we have sine 5x. Yes, if you now simplify this, it would be sine 10x. Yes, because indices will get multiplied, and in the above we have, so you just have to substitute the value, that's all. It is finished now. 2x plus 5x4 times gx is sine 5x minus 5. I am just substituting the value, that's all. We have a very little space here, so it is x square plus x5. Okay. Okay. So this is a way to solve differentiation when you have product of two functions or divisions of two functions. Okay. So let us now solve some general problems based what we have learned today. We have learned chain rule, we have learned division formula, multiplication formula. So together with this, let's work out some numerical examples. Okay. So let's say fx, or let's write this as y. It will be easier. Problem 1. Say y equals, say, x square sine square of 5x. Okay. You have to find, it is 5x. Okay. You have to find dy dx. Yes. So how we are going to solve it? See, here you have product of two functions, right? fx, gx, and again, as what we did just now, this gx is this function is in the form of composite function, right? So, okay, so our f is x square and our g is sine square 5x, right? So dy dx formula is f dash g dash f plus f plus of these two expression. Yes, now our f dash is 2x, our g will remain same. Now we have to differentiate our g dash, which I am going to do in the rough, and our f is x square g dash. Now g dash we will calculate from here. We have g equals, you better try this by yourself. Okay, don't follow entirely, try it by yourself, only then you can learn. Okay, so we have our gx is this, therefore g dash x. How we have to evaluate it? So here observe that we have three different functions in the sense u is 5x, v as sine u, and then we have v square, that is our g, right? Yes. So we will apply chain rule, dg dx. G has direct connection with V, therefore dg dv, and then V is dependent upon u, dv du, and then you have x du dx, correct, from the chain rule. Now what is our dg dv? 2v. What is our dv du? Cosine u. What is our du dx? 5. Yes? Any doubt? dg dv 2v, dv du cosine u, du dx 5. Now substitute the value. 5 times 2, our v is sine u, cosine u. 5 times 2 sine 5x, substituting the value of u, cosine 5x, we obtain here 5 sine, yes, 10x, right? Isn't it so? 2 sine theta cosine theta is equals sine 2 theta, right? Yes, so here we have 2 sine theta, our theta is 5x here, cosine theta is sine 2 theta, yes, theta is 5x, so 2 5 10x, yes. Okay, so we obtain from here 2x times sine square 5x plus x square times g dash x, our g dash is times 5 sine 10x. Simplifying, we obtain 2x sine square 5x plus 5x square sine 10x. Okay? Okay, let's do another problem. Square root of x times 10 cube square root of x. Same procedure. We have f is root x, g as 10 cube of root x. Yes. So what is our dy dx? F dash g, g dash f, symbol is plus. Now we know f dash is 1 by 2 root x times g, f, simply put f. Now you have to differentiate g dash. Try it by yourself. We have our g as 10 cube of square root x. Similarly, see, we have so many functions involved here. So let's start with beginner one, root x, u equals square root of x, v equals tan u, yes, and then g is v cube, correct? Because you can write this in this way, right? Tan square root x. Basically, you will start from the beginning. I mean, from the smaller, which is completely inside. So, how you can evaluate? I mean, how you can define this function? Okay, so this is a trick actually. I mean, you have to practice. See, basically, what you have to do, you have to start which is completely inside. So here, like in the earlier example, see, which function was completely inside? This 5x, right? 5x was completely inside. So you start with 5x. Then if I put 5x equals u, then what is happening? It is coming sine u, right? It is basically sine u square. So then you put sine u as v, then v square is g. Similarly here also, which function is completely inside? Root x is completely inside. Then put that as u. Then what is happening? You are getting this tan u. Yes. Then take tan u as v, then finally you are getting g equals v cube. Now apply the chain rule, then you are finished. So dg dx is, so g is directly dependent with v, therefore dg dv, v is directly dependent with u, therefore dv du, then u is directly dependent with x, so du ultimately we obtain x here. So dg dv is 3v square, dv du, differentiation of tangent u is secant square u, and du dx is half root x. Yes, now substitute the value, you are finished. 3, our v is tan u, secant square u by 2 root x. 3, now our u is tan root x whole square times secant square root x times 2 root x. Now substitute the value here. We are done. I need to use blue color here. G. Now I am just doing some simplification, that's all. Our problem is done. Root x times this root x and this root x will get cancelled out. So cancelling out, I am writing the final version. This is half 3 tan root x square times secant square root x. Yes? Yeah. So this is the final answer. Let's do one more problem. Let's say y equals sin x upon secant 3x plus 1. Okay. So what is our dy dx? Let this one is f, this one is g. So we have our dy dx as f dash g, g dash f upon g square, and the symbol is minus. Okay. So we know straightforward f dash is cosine x times g and sin x times g dash by g square. We just have to evaluate this g dash. Okay. We are evaluating g dash x here. Let gx secant 3x plus 1. Now which function is completely inside? 3x plus 1, right? So u is 3x plus 1 and v is secant u, right? Therefore dg dx and g is v. Therefore dg dv dv g is v, therefore dg dv, v directly dependent on u, therefore dv du, and u directly dependent on x, du dx. Dg dv will be 1, dv du, secant u, differentiation of secant u, it is secant u times tangent u, and du dx is 3, right? So you obtain 3 secant u times tangent u. Now substituting the value of u, you have secant 3x plus 1 times tangent 3x plus 1. Okay. Now substitute the value here and then you are done. Cosine x times secant 3x plus 1 minus 3 secant 3x plus 1 times tangent 3x plus 1 times sin x, right? Yes, upon secant square 3x plus 1. Okay. Okay. I hope this part is clear now. Okay. If you have any doubts, do let me know in the comment section. Anyway, it is very simple, but still if you have any doubts, do let me know. Okay.